Today we're going to continue working on section 5.6. We're looking at something called the fundamental theorem of algebra, and our learning target is to use this fundamental theorem of algebra to solve a polynomial equation with complex solutions. So a quick review from yesterday, we had the rational root theorem, which told us that the possible rational roots, so this is basically just making my list of possible things that I could try. To do that, to make that list, we need factors of our constant. So factors of 15, we've got 1, 3, 5, and 15, divided by factors of our leading coefficient, or this 2. And the factors of 2 are 1 and 2. So we want all the pairs of numbers that we can make with one of those numerators and one of those denominators. So we're going to have positive and negative options for each one of these. We have 1 divided by 1, 3 divided by 1, 5 divided by 1, and 15 divided by 1. Then we go back and take 1 and divide by 2, 3 divided by 2, 5 divided by 2, and 15 divided by 2. So we have all of those positives and all of those negatives as possible zeros. Also remember that our degree tells us how many we have. So if we have an x to the third, that means degree 3. So we're really looking for 3 roots or zeros. So obviously not all of those will work. When we have a higher degree polynomial like quartics or higher, once we synthetically divide out a root, we're going to use the leftover polynomial to continue that synthetic process, divide out another root. And we're going to keep doing that until we get down to a quadratic polynomial left. Because once we get down to quadratic, we have methods for solving. Like we can factor, use the square root technique, or always the quadratic formula will work. Okay? So again, we're going to go through that process looking at our power here. It is a 4. So we know that there are 4 roots or zeros that we are looking for. Okay? Then we make our list. Our list needs factors of our constant, factors of that 4, divided by factors of 1. So we have plus and minus. Factors of 4 would be 1, 2, and 4. Factors of 1 are just 1, which doesn't really do anything, dividing by 1. So we could have positive or negative 1, positive or negative 2, positive or negative 4 as possible zeros. Our next step is to look at our graph. This stands for graph suggests. So go ahead, I'm going to pause the recording and let you type in this polynomial into your graphing calculator, and let's look at what zeros we seem to find on that. All right, so looking at our graphing calculator, I've entered our equation. We're going to just do zoom 6 to get a standard window here. And looking at my graphing calculator, it appears like we have a 0 or root at -1 and another one here at +4. So we're going to check to see if those fit algebraically what we think we're seeing here. All right, so our graph suggested a -1 and a +4. So what we're going to do is we're going to set up our synthetic process. And prove that those 2 zeros actually work. Okay, doesn't matter which order you try them in. I'm just going to do the order I wrote them down in. So the -1 first. Remember, we take our coefficients. So the 1, the -3, the -3, the -3, and the -4. So 1, -3, -3, -3, -4. Okay, synthetically, we bring down that first one. We multiply here, so -1 times 1. We put that in the next column, and then we add. Okay, do the same thing. Multiply, we get a +4. Adding, we get a 1. Multiplying, we get a -1. Adding, we get a -4. Multiplying, we get a +4. And adding, we get 0. And as long as we're getting a 0 here, that means it worked. It's one of my zeros or roots. And then what I can do is I can build off of the remaining polynomial. So rather than starting over, we want to continue with just this much. So we're going to drop off that 0 remainder. It's gone. Remember, this is my constant, my x squared, and my x cubed. Okay? But we're going to just keep repeating the same synthetic process. This time we're going to try the 4. Okay, we bring down our 1, multiply, and I'm going to get rid of the variables here so it doesn't confuse us. Okay, so we brought down the 1, we multiplied and got 4, we add, we get 0. Multiplying 4 and 0 is 0, adding we get 1. Multiplying the 4 and the 1, we get a 4, adding we get a 0. And again, we're getting 0 remainder, which means it did work. So we have proved algebraically that these two are in fact zeros. But remember, we're trying to find 4 zeros and we only have 2. So there's 2 more out there. So now we look at this polynomial that we have left. Again, our first number after that remainder is a constant. Next would be our x's and our x squareds. So we're looking at the polynomial x squared plus 1, and we want it to equal 0. We want to find those zeros. Subtracting the 1 over, and then we can square root both sides. So we end up with x equaling positive and negative, the square root of negative 1, which is I. So of my 4 roots, or zeros, same thing, solutions, all of it means the same thing. We had 2 real ones. We had a negative 1 and a positive 4 that we saw on the calculator and that we proved here synthetically. And then we also have the 2 imaginary ones, the positive and the negative I. All right, let's try another one. We have x to the 4th plus 4x cubed minus 12x squared minus 28x plus 35. So again, it's an x to the 4th, which means we should be looking for 4 roots or zeros. Looking at our list, we always have the positive and negative options. And our list would be factors of 35 divided by factors of 1. Again, dividing by 1 isn't going to do anything. So we really just have factors of 35, 1 and 35, or 5 and 7. Okay? Then we're going to go to our graph and look to see what it's showing us. All right, so let's go ahead and edit this one. Our equation for this one should be x to the 4th plus 4x cubed minus a 12. And remember, we're going to have to insert to move that over. So second delete is insert to give us space to put that 12 in. You can always retype it if you prefer. All right, negative 28x and a positive 35. Okay, we're going to graph it. Now we said we're looking for 4 zeros, and for this particular one, I'm seeing 4 of them on my calculator. Okay, however, some of them appear to be landing in nice integer values, and some appear to be landing in between our tick marks. So looking from the far left, this one appears to be at negative 5. The next one is somewhere between negative 2 and negative 3, and those were not numbers on my list. So I'm going to hold off on this one for a minute. It is a real answer. It's just not one of my nice rational ones. Okay? My next one appears to be at a 1. And then this 4th one here, again, I'm going to hold off on it because it's landing in between 2 tick marks, and I didn't have any fraction possible answers. All right, so we said negative 5 and positive 1 were what I see on my calculator. So we're going to build our synthetic setup here. Our coefficients are 1, 4, negative 12, negative 28, and 35. Okay? And again, it doesn't matter which order we try these in. I'm just going to go in the order I wrote them. So -5 first. We bring down our 1. We multiply the -5 and the 1. We put it in the next column, and we add straight down. Keep repeating that. -5 times -1 is +5. Adding gets us -7. -5 times -7 is 35. Adding, we get 7. -5 times 7 is -35, and adding, we get 0. So again, we're going to drop off that remainder that's gone, and we're going to build again off of my remaining polynomial. Okay, so I refer to this as just stacking them. We don't want to start over, because what we're doing is we're going from an x to the 4th. Now we're down to an x cubed, and if we do this one more time, we're down to an x squared. So that means we have a quadratic polynomial, which we can solve with other methods. All right, we're going to try this 1 to see if that works. Multiplying, adding, multiplying, and adding, multiplying 1 and -7, and adding. So it did work. We're getting 0 remainder, so we get rid of that. And we look at what we have left. My constant, my x squared. So the quadratic that I have left is a 1x squared minus 7. And we need to now find the zeros of that. We can add the 7 to the other side. We can then square root both sides. And we end up with x equaling positive and negative square root of 7. Okay, so my roots or zeros or solutions would be -5, +1, and positive and negative root 7. Now, if you think about it, the square root of 7 is a little less than 9, less than the square root of 9. So the square root of 7 is somewhere between a 2 and a 3. Okay, and if we go back to our calculator, remember those values that we had here? We had a number in between 2 and 3, same with 1 right here. Okay, so that's where that positive and negative square root of 7 is coming in. Okay, so it's a real answer, it's just not a rational answer. Can't be written as a ratio or fraction. All right, let's try one more. This time I want you to notice we're still looking for 4 zeros. Okay, I still want to make my list. I need factors of 36 divided by factors of 1. So factors of 36. 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Okay, again, all of them are being divided by 1, which doesn't do anything. Okay, we're going to look at what our graph suggests. So once again, we're going to pull in our graphing calculator. We have an x to the 4th plus 5x cubes minus, I'll delete that one out and change that to a 5, minus 5x squared. And then notice that I don't have any x's. So I'm going to delete that part out. And I have a negative 36. So because we don't have any x's, we do want to make sure and put 0 into our synthetic process to hold that space. All right, so based on my graph here, it looks like I'm hitting at a positive 2, which was one of the numbers on my list, and also here at negative 6, which again was a number on my list. So let's try negative 6 and positive 2. And once again, when we are doing this proof step, our coefficients are 1, 5, negative 5, and then a 0 since we don't have any x's, and then the negative 36. Okay, I'm going to start with the negative 6. We start with bringing down our 1 and multiplying these, negative 6 times 1, adding, negative 6 times negative 1 would be 6, adding, negative 6 times 1, adding, and again, negative 6 times negative 6 is 36, which is the 0 we were looking for. So drop that off, and we're going to continue from here with the remaining coefficients of my new polynomial. Now I'm going to try the 2, multiplying, adding, multiplying, adding, multiplying, and adding. Again, I'm getting 0 remainders, so I drop that off. And I'm looking at my remaining polynomial. This time I have 1x squared plus 1x plus 3. And I need to figure out what makes that 0. And because there's that x in the middle, I can't use the square rooting technique, so we are going to have to do the quadratic formula. All right, so x equals the opposite of b. b is a 1, so we need negative 1, plus minus the square root, b squared, minus 4 times a times c, whole thing divided by 2 times a. So negative 1 plus minus our square root all over 2. Inside our square root, that discriminant piece, we have 1 squared, which would be 1. We are subtracting 4 times 1 times 3, so we're subtracting 12. So negative 1 plus minus the square root of negative 11 all over 2. So we're getting two imaginary answers here. Negative 1 plus minus I root 11 all divided by a 2. And that's why on our calculator we only saw 2 zeros, even though we knew we were supposed to be finding 4. Okay, so my final answer, my zeros would be all right, roots are zeros. We had negative 6, positive 2, negative 1 plus minus I root 11 all over 2. All right, let me know if you have questions.